Live from Utrecht, this is Bitcoin
Explained.
Sjors, are we still making a bi-weekly podcast?
I mean, it depends on what you mean by buy. It's more like a feeling, right?
We make a podcast when we feel about it these days, is that the rule?
No, it's also when we're not traveling or sick or whatever.
Or we don't have a good idea for a podcast. This is a good moment actually to maybe make a call to our audience. Like, we will take requests for topics, or at least we will consider requests for topics if any of our listeners have good ideas of things that they want to have explained by us. Just let us know on Twitter and we will consider it. Is
Okay.
that right, Sjors?
No, that's true.
All right, so last one was, I guess, a month ago. I don't know when this one is going to be published because I think our editor is now traveling. He's in Amsterdam.
Oh, okay.
He's coming to our meetup tonight. We're recording this on, what is it, Wednesday?
Oh, Wednesday, 20th of April.
Yeah, and there will be the biggest meetup in all of Europe in Amsterdam tonight, Sjors. Isn't that exciting? We recently discovered that it's probably the biggest one in Europe, so now that's our main marketing push.
Interesting. I guess that's because there's nothing happening in Prague at the moment? Or
I mean,
because they have pretty big meetups.
I think it's also part. Yeah, I mean, we didn't fact check it, but I think it's the biggest one in Europe.
But you mean the biggest
also,
Bitcoin meetup, which then meets some like narrow definition of Bitcoiner or Bitcoin?
Just the biggest
Like,
Bitcoin meetup we know of. I don't think we're doing very narrow definitions.
I mean, there's Bitcoin Wednesday, which has nothing to do with Bitcoin.
Right. That's also in Amsterdam. I mean, is that bigger than ours?
I don't know.
Who knows?
Could be.
All right, let's get to the actual meat of this episode.
Indeed.
We are going to discuss. We'll probably have this published, I think, on the day that Bitcoin Core 23 is released, because that's what we're going to be discussing. Bitcoin Core 23.
That's always a bit of a risky statement because it can take a while before it gets released. But hopefully it'll be at the same time. Yeah.
Yeah. At the time we're recording this, we're on release candidate 5. I don't think there's been many Bitcoin Core releases that required more than 5 release candidates, right?
Indeed.
By the way, this is not in the show notes, but maybe that's a good starting point. Sure. What is actually a release candidate?
Well, it's a candidate for a release, to put it simply. So basically, it's a way for the Bitcoin Core developers, or really any software project, to give experienced user a chance to test the software.
Right. And what are they testing it for?
Well, they're testing something that's going to be as close to the final version as possible. In fact, the very last release candidate is eventually copied and called the actual release.
Yeah. So in this case, release candidate 5. I think they're basically guys like you, Bitcoin Core developers and other expert users, maybe they're sort of trying out the software, looking for bugs. And
yeah, exactly, or changes that are not correctly documented. So, for example, if you're running a Bitcoin ATM or something, and you're relying on a Bitcoin Core node to do all sorts of automated stuff, then you would test a new release candidate to make sure that all the automated stuff you were relying on, still works, and there's not some subtle change that causes your ATM to send free money to its users.
Right, and that lasts for like about a week, and then if no issues are found, the latest release candidate is essentially rebranded to whatever the new Bitcoin Core release is. So,
well, yeah, I mean, there is an actual new release made, but it has the same code in it. The only thing that changes then is the version number. So yeah.
Right. Okay, so Bitcoin Core 23, that's where we're at.
Yep.
For those that don't know this, Bitcoin Core releases a new Bitcoin Core release every 6 months, more or less.
Mm-hmm.
And the new Bitcoin Core release will basically just include whatever was ready at that time. Bitcoin Core doesn't wait for specific features. It's just once every 6 months, whatever's ready is in there, right?
Yeah, that's right.
Okay, so we're going to discuss some of the most notable changes. Let's begin. Sure, we're going to begin with there's something about ports.
Yes. Yeah. So as you may or may not know, Bitcoin Core listens to other nodes if it's on a public network on port number 8333.
Yeah, and by listens, you basically mean just communicate with, right? Or
what's
some more?
Listening means that it is listening to the outside world, so you can actually connect to it if you're in the outside world. A node could also just be on the internet but not listen to anyone in the world, so you might not know where it is, and even if you send a message to it, it won't hear you.
Right, so if I'm running a Bitcoin Core node and it's a listening node, which is like a setting?
It's actually the default. However, in your home situation, it's not going to listen by default.
Right.
And that's not because of a setting in Bitcoin Core, but other reasons we'll probably get into.
Yeah, we'll get into that in a bit. So, but essentially, if I'm running a Bitcoin Core listening node, let's just call it that for now, and you, Sjors, you're also running a node. And if you want to communicate with my node, if you want to connect with my node, then you're going to connect with my node on port 8333, right? So far, so good?
That's right.
Okay, so what is a port? What does this actually mean?
So a port is part of I believe it's the TCP protocol, the TCP IP protocol, basically. So the idea is an IP address is where the computer is. That's what it tells you.
Mm-hmm.
And the port is actually just a thing inside of the messages that you're sending it to it. So, the internet uses packages, and these packages, they have a certain structure. And the beginning of the package says, okay, this is the port I want to communicate on. So it's just a convention, a kind of a way to talk to different services on the same machine. So one server on the internet might run a web server, and it might also run an email server, and it might run a Bitcoin node. And so one convention you'll use is if you want to talk to the web server, talk to port 80 or port 443. If you want to talk to the FTP server, talk to port 21. If you want to talk to the Bitcoin node, talk to port 8333. So it's kind of like if you're sending somebody a letter and you write down the number of whatever the office they're in.
Yeah, or the name in that case, right? There's several people living on the same address, and then the name actually specifies who it's for.
Yeah, maybe two. Yep.
Yeah. So
these are conventions, right? So IP addresses are a scarce resource. They're distributed across the world. So there are some centralization involved there. But when it comes to ports, there are standards and conventions out there, but your machine decides what it does on which port. There's nobody on the outside can tell you what to do. Yeah, it's just a very bad idea to use the wrong port.
So your computer connects with my computer. It tells my computer I'm going to use port 8333, which is just convention, a specification of something we chose. Uh-huh. And at that point, my computer knows, that means he wants to connect to Bitcoin Core, right?
Yeah, because Bitcoin Core told your computer that it wants to listen on that port.
Right. So and that's the convention, but there's a problem with this.
Yeah. So one thing is that internet providers and others can filter the internet traffic. And one way you can filter the internet traffic is just by looking at which port a package is going to, because that's very easy to see. It's at the start of each package. And you have to check that anyway for other reasons. So one thing an internet provider could do is just say, well, we don't like Bitcoin. Let's just block port 8333 specifically.
Right. So in a very sort of Bitcoin hostile future where perhaps Bitcoin is banned or whatever, and ISPs want to stop people from using Bitcoin, this would be one way for them to do it.
Yeah, this would be the easiest, the lowest hanging fruit way to do it. It's certainly not a very effective way to do it, but it's one start. It's certainly also not the only thing they can do.
And the reason it's not very effective is because we have the option to just use different ports.
Exactly.
Is that right? Right.
So that's the cat and mouse game. So if they make that move, then the second move is, okay, we just start using other ports. But in order to prepare for that situation, I guess, one of the changes that are in the new version is that Bitcoin nodes will connect to other nodes that have a different port.
So they don't do that now?
They will do it if you tell it to. But one thing we talked about in the earlier episode is that your node keeps a list of other nodes that it could connect to. And from that list, it tends to pick nodes that have port A333, and only if that fails after a long time, then it'll try other ports. And that's the preference that's being removed now. So it'll just try any other node regardless of what port it has, which means that if we move to such a future where nodes are listening on different ports, it's not, it's going to be less friction.
Right. So right now you're running a node, Sjors, and by default, your node will try to connect to other nodes, and then it will prioritize port 8333 nodes. Yeah. And so if I'm running a node on another port, then and everyone is like you, then I will just not have any inbound connections from other nodes because everyone's sort of ignoring me because I'm not using 8333. Is that right?
Yeah.
Right. So, and this is changing now. This is changing new Bitcoin Core where you won't prioritize 8333. You'll just connect to whatever node.
Yeah, exactly.
Right?
And there is, I think, a list of nodes, a list of ports that we don't connect to because it could be perceived as an attack. But I think that list is pretty short.
Right. Okay, so this is basically preparing for a potential dystopian future where Bitcoin is very much.
I mean, Bitcoin is always preparing for a potentially dystopian future.
And it
so
should, yeah. But just to clarify that for the listener, I
Yeah,
guess.
but also
So
to
that-
clarify this, this is not going to make the difference. It's like just one chess move, and the counter move is pretty obvious. So there's all sorts of ways for internet providers to see that you're running a Bitcoin node,
Right.
not just the port you're on.
Okay,
But
got
that's the easiest way, and enemies are lazy, so
it. Okay, well, so that covers that change, correct?
yeah.
All right. Let's move on to the next point. Sorry, I'm mispronouncing it already. CJDNS.
Yeah.
That-
Yeah, I have no idea what it really is, to be honest. It's kind of in the list of you have Tor and I2P that we talked about, and it's not a complete replacement of these things, but it's sort of similar-ish.
So it's some kind of anonymity network that you can use if you want to use the internet more privately.
Exactly. And so if you know what that is, now you can use it with Bitcoin Core. I think that would be the first step to put it.
So Bitcoin Core has included support for CJDNS.
That's right. And so in the beginning, so a couple of episodes ago, we talked about the address gossip messages and how it used to be that we could communicate IPv4 addresses, IPv6 addresses, and Tor v2 addresses. And that, wasn't possible to communicate Tor v3 addresses because they were too long, yada yada. And so they come up with a new standard called address message format number 2, which allowed you to send addresses of very different sizes and very easily add new networks to that. And this is just one of the new networks that's added to it. So these nodes you can't just use it, you can also gossip them around and things like that.
Right. Details about CJDNS itself is not something that we can provide to the listener, I think, or at least that's sort of outside of or at least outside of my expertise, and I think outside of yours as well.
Yeah.
Okay, but it's Bitcoin Core supports a new privacy, or is it new? Do you know if it's new?
I don't think it's new.
Okay, it just supports an additional privacy network. If you want to use it, great.
Yep.
I like it, Sjors.
Next.
Next. Yeah, so there's an upgrade in the fee estimation algorithm in Bitcoin Core.
Yep.
So obviously, whenever you want to make a transaction, Bitcoin Core has this option to increase or decrease the fee depending on how fast you want your transaction to confirm, which depends on things like how many transactions are in the mempool or how high fees were in recent blocks. I think these are sort of some of the inputs.
I think it looks at
made.
Yeah, exactly. I think it looks at how high fees were in recent blocks, but it also checks how long it took before it first saw it in a mempool and when it was in a block. I'm not exactly sure.
Right,
but
so that has been upgraded to include RBF, replaced by fee transactions. Is that right?
Yeah, I mean, you could call it an upgrade. I mean, initially it would just consider all transactions in the mempool, but then when RBF was introduced, I think it was decided to ignore those RBF fee bumps. So a fee bump is like you increase the fee of an existing transaction, and in the beginning, I guess developers were not sure whether miners would actually play along with that game, so like actually replace the transactions. And so because they weren't sure about that, it was a bit risky to take those fees into account because you didn't know if those fees actually mattered or not. But they do, and more people are using RBF. So now the fee estimation takes into account the fees of the transactions whose fee was bumped.
Right, and so to be very clear about that, the fees we're talking about here, the RBF transactions we're talking about here, are essentially other people's RBF transactions.
Yeah.
Right. So to reiterate that really quick, RBF, you send a transaction and it's taking longer to confirm than you anticipated, or for some reason you're in more of a rush all of a sudden, then you have the option to basically resend the same transaction to the network, but include a higher fee this time. And that newer transaction should sort of override the older transaction. The miners should pick that one because it has a higher fee, essentially.
Exactly.
So then the transactions that are going to be confirmed in blocks essentially have higher fees now if all miners will adopt or accept these RBF transactions. And therefore, your own transaction, if you're going to send it, would also require a bit of a higher fee. And that's now taken into account.
Yeah. I mean,
right?
just the one nuance there is not necessarily that the fees will actually go up, right? Because people will make more conservative estimates and then increase them. So effectively, fees might be lower. But yeah, basically you have to take them into account. You have to look at what transactions actually go into the block.
Well, your own estimate, the estimates that your Bitcoin Core client makes, like let's say I want to have my I want to have my transaction confirmed within 24 hours. Now that it is taken into account, RBF transactions from other people should mean that my fee estimation will be slightly higher now, right?
Well, that's what I thought yesterday too. But now that I think about it, I think that's not actually true, because RBF transactions, what it's saying is it's now including transactions that have been fee bumped. Yeah. But I don't know if it previously excluded those transactions or excluded transactions that were using the RBF flag but were not fee bumped.
I don't get that at all.
So there's three kinds of transactions. There's three kinds of transactions, right? There's transactions that don't use RBF at all. There's transactions that set the RBF flag but don't bump the fee, and there's transactions that have now a higher fee.
Yes.
Yeah, so the transactions that now have a higher fee are always higher than the ones that don't. So yeah, I guess you're right. It would increase the price, the fee estimates slightly.
It would have to, right? There's no way it can be lower if it's going to take into account RBF transactions. So it might stay the same. It depends. Some cases. It's either the same or higher.
It depends. If it was discounting all RBF transactions, regardless of whether the fee was bumped or not, then it's different. Because if the algorithm was only looking at transactions that don't have the RBF flag at all, and now it's also looking at transactions that do have the RBF flag, those might be all systematically lower. So
yeah, I guess that's true, but that would be strange policy if that was the case.
It may be, but that would be a good reason to revert it. Yes. So I guess we should have read the pull request a bit better.
All right,
you can do so yourself.
In either case, that's kind of a detail. The important thing is RBF transactions are now taken into account for fee estimation. Essentially, to summarize that in one sentence, fee estimation should be a bit better now.
Yep.
All right.
Let's talk about Tether.
Let's talk about Tether. Sjors, you want to talk about Tether?
Yeah. Is it actually Tether? USDC?
That's another one, right?
I think
Tether should be USDT or something like that.
Well, anyway, it is USDT.
It does say,
I actually just wrote it wrong in the show notes. Yeah, it's right. USDT, but it doesn't stand for Tether. It stands for User Space Statically Defined Tracing for Bitcoin Core.
Aha! It's only now that I understand your pun. Then you made a pun in the show notes. That's great. We're back to puns. We need more puns in our show, but I make the pun again because maybe people didn't get it.
No, that's fine. They can re-listen to the episode. Right. And I kind of ruined it anyway. So the basic idea here is that I don't really understand what the basic idea is, but trace points are tools that developers can use, but also people who want to monitor their own node can use to get really fine-grained statistics out of their node. So, for example, you can ask your node for things. You can call the node RPC. You can say, okay, give me the list of blocks you have, or give me the list of peers you have. There's a RPC call for that. And you can read log files, and that tells you something. But this is just another way to get more detailed information. So one of the details you can get is every message that every node ever sends to you. So all of your peers keep sending you all sorts of messages, and now there's a better tool that you can use to kind of track those messages in a database.
Okay, well, let's break this down a little bit. First of all, this seems to me, this sounds like something, this is useful for developers specifically, right? Or is this something users are going to use for some reason?
I would say developers, but also say researchers, like, Jameson Law, for example, when he does all these analysis of whatever's going on,
right?
He could use this, or I think security researchers might find this interesting because they could run a bunch of nodes and check all the message traffic that's coming at those nodes and maybe identify attacks by something subtle, right? So sometimes, like we talked about an attack on the Bitcoin peer-to-peer network a few episodes ago, where people were announcing fake nodes. And that's something you probably wouldn't be able to detect if you just looked at, if you just start your Bitcoin Core GUI, it doesn't get hot or it doesn't scream at you, yet there is an attack going on. So these kind of tools would make it much easier to see that this attack is going on.
Okay, so one small step back, just for my own understanding, and I guess the listeners as well, since they're listening, hopefully.
That's why we explain things.
First of all, you just mentioned log files. So a log file basically keeps track of every action your Bitcoin Core node does, right?
Depending on how you configure it, you can tell it to keep track of quite a lot of detail, yes.
Yeah.
But it's just a long text file,
Mm-hmm.
and each line has starts with the timestamp, and then it says, okay, this happened, and then if you want to process that data, it can be quite tedious,
Right.
and
But-
not everything goes into the log file either.
Okay, but this was already possible.
Yes.
And so now we're talking about user space statistically defined tracing. And if I'm trying to understand you, it's like a more specific type of log file. It tracks more specific things, or
that's what I understand too, but I don't completely understand it either. But I guess it really ties better into the operating system, and it's a way to communicate this information in a more structured way than just a text file.
Right. So the example you gave was something related to the peer-to-peer network. You give it a very specific instruction. You don't have to log everything. You just log whatever other nodes are communicating with you, or whatever data other nodes are sending to you, and that's sort of Bitcoin Core now has the option to keep track of that in a way that's easy to understand by other types of software, perhaps.
Yeah, exactly.
Right. So, as you mentioned, useful for developers, useful for researchers, not something a regular user will use in general.
No, I don't think so.
Okay. That's pretty clear to me. Oh, I completely lost access to the to our show notes. There we go.
Oops.
I'm back.
You're back?
I'm back. Next point, Sjors. Are you ready?
Yeah, I'm ready.
Bech 32. How do I pronounce Bech? Is that how I pronounce it? That's probably a very Dutch way of pronouncing
Yeah,
it.
I would say Bech 32, but others say Batch 32.
Batch, yeah. BECH 32. Batch 32. I forgot why this is in the show notes, but I'm sure you remember.
So, as you may remember, the Bech 32 checksum has some nice properties. One of them is that it allows you locate where your typos are.
Yeah, So, batch 32 is a type of address.
Yep.
And this type of address has we did a previous episode on addresses. Sjors, which episode is that?
Yes, we addressed this.
Oh, great.
I think it was probably episode 2 or something.
It was pretty
early,
early, I think, yeah.
And one of the things we explain, indeed, is that this new address format that starts with BC1 will have the nice property that if you make a typo in it, you can actually find out where it was to do mathematical magic. And so that was already possible in theory, but it wasn't supported in practice. And now Bitcoin Core will let you do it, at least if you use the command line in this release, and then maybe in a future release, there's already some work for that. You can do it in the GUI.
Right. So if someone for some reason would, type out an address instead of just copy paste, and they make a typo, then your Bitcoin Core client will tell you there's a typo in it and it's there, right? That's basically what will happen.
And there's some discussion about up to what point that's safe, because there's it could be situations where you make too many typos, and then it might think you actually meant another address, and it might actually help you accidentally change the address into a different address, which is even worse than the address not working.
Sure. It's kind of like autocorrect in that sense.
Yeah,
where
but if you're using the command line,
word.
yeah, if you're using the command line, then you should know what you're doing. So it's easier to introduce these features there.
Yo, what is going on, guys? We are proud to have Voltage as a sponsor of this episode. How many of you developers out there have wanted a streamlined infrastructure provider for your particular project? Well, I'll tell you what, Voltage is the Bitcoin infrastructure provider you have been looking for that makes building on Bitcoin quick and easy, whether it's Bitcoin nodes, Lightning nodes, BTC Pay, and so much more. But don't take it from me. Just ask the guys over at Amboss, Sphinx, Podcast Index, and Thunder Games, and so many others that you guys already know and love. Their enterprise-grade products make it fast and easy to build, deploy, and scale your next project. So make it easy on yourself. Even normie plebs can use the dashboard or API. Don't wait before the next block confirmation. Let your team focus on building great products and let Voltage handle all the rest. Voltage is your go-to zero management Bitcoin infrastructure solution.
Nice. All right. Next point. We're getting there.
Yeah, new
Two or three more to go, right? All right.
Yep.
Wallet support for Taproot.
That's right. I think more precisely, new wallets will support Taproot. So if you create a new wallet, it will have Taproot support. It won't use it by default, but you can. So the other change there is that there's a little drop-down menu where the checkbox used to be for Bag32.
Mm-hmm.
Now there's going to be a drop-down menu where you can choose, where it still uses SegWit by default, but you can actually select Taproot as well.
So what does that exactly mean? Like, what does it mean to use Taproot in this
context?
Well,
you'll get an address that starts with BC1P instead of BC1Q.
Right.
And it's a Taproot single signature pay-to-public key.
Right. So it doesn't mean that you're somehow automatically using all the fancy multi-sig options and time lock options that are all sort of hidden in this tree. It's still a regular single key transaction, but you are using a Taproot address. So
which has almost no benefit, but you can do it.
Yeah, it has a little bit of benefit for yourself. The point in this case, I guess, is that anyone monitoring the blockchain, that's sort of one of the nice things about Taproot. They won't be able to tell if it was in fact just a single key transaction, or maybe there was like a fancy script hidden behind it. It looks the same.
That's right.
Right. So we're kind of working towards this future. Like that's part of the vision of Taproot, where every transaction kind of looks the same.
Yep.
And people won't know what kind of transaction is really sort of hidden behind it. And by moving in this direction, I'm repeating myself, but we're moving in this direction.
The transition phase is always a bit risky. Right. Because now, how many wallets actually can do this? Not that many. So it might actually tell people that you're using Bitcoin Core, but yeah, that's something to think about. But it's not the default yet. And the other reason it's not the default is because some wallets cannot send to a Taproot address.
Yeah, in the short term, in the transition phase, you're arguably a bit worse off privacy-wise. But then once people migrate to this new standard, then everyone should benefit. That's basically the short version of the story here, right?
Yeah.
Okay, so we're heading in that direction. You can, next point, in case that wasn't clear, we're moving to the next point. You can now freeze coins in your wallets.
Yeah, so it was already possible when you're using the Bitcoin Core GUI to send coins. You have something called manual coin selection that you can turn on if you like to actually decide which specific coins you want to spend. And it'll give you a nice depending on who you ask, graphical display of which coins you have. And you can select boxes and say, I want to use this coin, I want to use this coin. Yeah. And it also had the opposite feature where you could say, well, I don't care which coin to use, but don't use this one and this one and this one because they come from some bad source that I don't want to mix with my other coins.
Well, that's the new thing, right? What you just said.
No, it was already there. Oh. The only problem is you have to do it every time you want to make a new transaction. It didn't remember it.
Right, right. Yeah, so, I mean,
at least not between startups of the Bitcoin Core. Yeah.
Right. So you're saying coins, which is also what I often use. It's the easy to understand thing. Technically, they're UTXOs, of course.
Yep.
They're just, the fractions of Bitcoin that you received over time that are in your wallet. And it was always possible if you make a transaction that you tell your Bitcoin Core wallet, I want to use these fractions to create a new transaction. Or, like you said, don't use these fractions to create my new transaction.
Right.
So don't use these new fractions to make a new transaction. That feature is now, you can basically tell your node, don't use these fractions until I tell you otherwise.
That's right.
For the rest of time.
Yeah, exactly. It remembers it.
Right.
And that can be nice. Like, there's a couple of reasons. Like I said, maybe your wallet has lots of coins from KYC places, KYC free places, but it has one coin that you got from Coinbase. And you just never want to use that coin from Coinbase because then Coinbase can tell all your other coins as they're spying on you probably.
Right.
So that's, so you can basically mark that coin as toxic until you decide to spend it. Yeah, it remembers that. But it can also be if you have something like a dust attack. So somebody like an analytics company might be sending very small amounts of dust, those very small amounts basically, to Bitcoin addresses that it knows about, and then it's hoping that your wallet will automatically grab those coins and combine them with the other coins in your wallet, thereby revealing that you own that old address and as well as the new address. So now you can disable those two if you see this attack. It's pretty advanced stuff, but it's nice too that it works.
So freezing them is like a manual thing. You click a button. Oh, sorry. Freezing is like a manual thing. You click a button, now they're frozen. And then unfreezing is also a manual thing. Or could you also say, don't use them for a year, and after a year they're automatic?
No, it's not that advanced. You just select it and you deselect it.
Right. All right.
We have a bonus item.
Exciting. This is very exciting. A bonus item, Sjors. I cannot wait to hear what the bonus item is.
So as we mentioned, there were multiple release candidates. And then there was release candidate number 4. And somebody on Windows found a bug. And it was a very obscure bug. It's like, if I go to this screen and then this other screen and I wait a few seconds, my node crashes. So this is something many people would not even test, because when there's a new release, you generally test things that are new in that release. But in this case, somebody was just testing existing functionality and ran into this crash. And people investigated it, and it turned out to be some really obscure Windows-only bug in the C compiler that Bitcoin Core is using. And so people actually had to fix a C compiler in order to fix Bitcoin Core, and that took another couple weeks.
Right. So the C compiler, that's not even part of Bitcoin Core. That's just a separate program in Windows that will compile your code into binaries, right?
Yeah. Or a program on Linux probably that will compile your code so that it runs on Windows.
Right.
Yeah.
So, and there was a bug in that separate piece of software in the compiler, and therefore a bug pops up in Bitcoin Core.
Yeah, but only in Windows and only in that specific place. So it was very lucky that people even ran into it. I mean, that specific bug wasn't the end of the world. It's very annoying. But, if there's a bug in the compiler that can cause things to crash, you don't want to think about what other things that bug could cause. So it's better to just deal with it.
Right. We've also made an episode about this, Sjors. Which episode was that?
The episode about geeks, basically, where we talked about dependencies and the dependency circus.
Right. So here we have a concrete example of essentially a dependency having a bug and therefore causing problems in Bitcoin Core. So how was this solved then? Is this solved?
Yeah, I believe it's solved.
So
I think there was a... So there's two ways, two things usually that happen at the same time. One is once you figure out what it is, you go to the developers of this dependency project, so the compiler people probably, and you tell them this is broken and here's how you can fix it. And then they will put that into their normal flow, and eventually they'll release an update where it's fixed. But you may not want to wait for that. So there's something called patches, where in Bitcoin Core there's a bunch of these small snippets of code that before Bitcoin Core is compiled, it first patches whatever needs to be patched, and then it compiles. So basically, Bitcoin Core creates a little patch that fixes the compiler before it builds Bitcoin Core.
Oh, who creates these patches? Bitcoin Core developers, actually.
Yeah.
All right.
Well, whoever fixes the original issue, right? So it could be a Bitcoin Core developer that fixes the issue for the compiler people. It could be the compiler people that fix the issue themselves, but they haven't published the fix yet. They haven't published a new binary for the fix yet. So then you would just copy-paste their fix. It doesn't really matter who does it.
Right. But in this case, do you know who created the patch by any chance?
Probably Fanquake, but I'm not sure.
Right. So someone created this patch, fixed the upstream problem, or is it downstream? Is it upstream or downstream, Sjors?
I think it's upstream. Yeah.
I would say upstream, right?
Yeah, I would say upstream.
Yeah, it has to be upstream. So someone fixes the upstream problem, and now Bitcoin Core should be compiled without the bug. So that's release candidate 5.
Exactly.
Well, we're testing that now, I guess, while we're recording this podcast.
Yeah, and then hopefully nothing else is broken, and then it can be released.
Great. Where do people find this software if they want to download it?
I think if they want to test a release candidate, they should go to probably the Bitcoin developer email list, where there's an announcement that says, hey, you can download the release candidate here. If you just want to wait for the real thing, it'll show up on bitcoincore.org eventually.
All right, great. I think that covers it, Sjors.
Cool. Well, thank you for listening to Bitcoin Explained.